Welcome to another episode of Dominic Does DIY. As always, like, subscribe, and comment down below if you find this entertaining or useful. Also, if there's something you'd like to see or explained, let me know in the comments down below. Now, let's get on with the design. So today we got a simple problem. We have an intern under your command and asked him to do a simple passive 3-stage high-pass filter for 300 Hz. Basically, we just want to stop all DC voltages from getting through into the rest of the circuit. He lays out a circuit using some 0.1 microfarad and 5.1K resistors, which you can see here. He runs an AC analysis on it. So let's go to run an AC analysis on this V3 right here. And you can see in the AC analysis, we have some pretty not highly good roll-off, but it's fine. So when we're inspecting this, we can see, remember we had it for 300 Hertz. So we can see at about 300 Hertz, which is about here. We're at about minus 16 dB, right, which is pretty good. We can go all the way. Our minus 6 dB point is roughly about like 1 kilohertz. And if we go up to 8 kilohertz, which is what the system was going to be designed for, we're pretty much at 0 dB at that point. So it's not the best, but it is good enough for what we were wanting to do. Remember, we just want to kill the low frequency noise. If we can get up to anything above 8 kilohertz is 0 dB. So this will work fine. We don't need to go into too much investigation on the filtering itself, right? It works. So after he got the Bodie plot going, and he was like, okay, I've got my dB accurate, and it's working good for my frequencies. He decided he wanted to go ahead and run a transient on it to see what the input versus output was going to actually look like. So when he ran the transient, he got a little something different that he wasn't expecting. He was looking at it and he was like, well, why is my output going negative? He was wondering, why is it minus 2.5 to 2.5? So he checked his input to see if he had hooked up the input correctly, and lo and behold, he did. His input is going from, if we select that, we can kind of see it and roll over. We can see it goes from pretty much 5 volts all the way down to 0 volts. So his input, which is this blue-purple, sorry, colorblind, this VN right here, this blue-purple, it goes from 0 volts all the way up to 5 volts. But his output goes from minus 2.5 volts roughly to positive 2.5 volts. And he was curious about why this happens. So he comes back to you and he asks you that question. How come when I have an input of 0 to 5 volts, I get an output of minus 2.5 volts to positive 2.5 volts? Pause the video now if you'd like to take a moment to find the solution. So for this solution, we need to consider two things. First, we need to consider what is the probe in the simulator measuring, and second, what is happening with the voltage on the input. Well, the voltage on the input in the system. To answer the first question, the probe in the simulator will measure voltage at the point selected to the system ground. So in here, the system ground is this triangle. So if I just click on this point here, it's going to give me the voltage from this point to the system ground here, right, according to the simulation. That's just a single point reference. You can do other things in here. This is a differential probe where you click, hold down, and you see I have a red and black, and now that'll give me the voltage across the capacitor, or if I want to do this, it'll be the voltage across the 3 capacitors, right? But a single point like that is just going to give me the voltage at this point with reference to the simulator system ground. And so when I do that, we can see that it goes from negative 2.5 to positive 2.5. To answer the second question, it is a little more involved. So if we take a look at the AC signal, AC source, you can see it's actually a combination of two things. There's an amplitude, there's a sine wave function to it, which is the amplitude and the frequency, and there's this DC offset of 2.5 volts. So if you have an amplitude of 2.5, that means like from center up, center down. So peak to peak would be 2 times the amplitude, which would be 5 volts. And then you got your DC offset, which is your 0 marker. So if I take a look at my VN, you can see that indeed, VN, it goes from 0 volts at the low end here which is 0 volts over here, and you can see it goes up to 5 volts, right, which is exactly what we would expect with a DC offset of 2.5 and an amplitude of 2.5. But when we go to the output seems to only have the sine wave amplitude and no DC element to it, right? Because we have a 0 reference center, and it then has an amplitude of positive 2.5 and then minus 2.5. So it looks like we get the sine wave without the DC offset. So then why did we lose the DC offset? One answer can be this C1 right here. This C1 right here is a DC blocking cap. With the C1 there, the DC blocking cap, no current can go through on the DC element, so the only thing that's going to pass is the AC element of this voltage source. Right? And so that's why we can see the amplitude and everything, but no DC offset. All we see is the positive and negative. So you may think, well, that may be the solution. That's why we see on Vout, we see 2.5 to negative 2.5, is just because of that DC blocking cap. Otherwise, it's just a low-pass filter that's working exactly as expected. But just to verify this, let's change out this AC source, right? That has the AC element and the DC element to it. And let's just change it out for a DC-only source. So here I changed out the input. Now we just got a DC source, it's just a pulse from 0 to 5 volts. No DC offset. And then what I did is I just made it a triangle wave to try to mimic the sine wave in a DC format. So still 8 kilohertz. I rise on 62.5. I go down 62.5. I stay on for just 1 nanosecond, just like a short time. And my full period is 125 microseconds. So 8 kilohertz signal, but in a triangle wave. And so now if I run that, you can see, got exactly what I wanted. My input is still a triangle wave, and still keeps those things from 0 volts. You can see to 5 volts, right? You can see 0 volts over here, and I got my 5 volts up here, over here, 5 volts. But then if you look at the output, right, we would expect that if the negative voltage aspect was just based on the fact that it was a AC sine wave, then we should just still see positives on Vout. But if we look at Vout, we can still see that we still go to about minus 2.5 volts on the low end, and our high end is still at around a little under 2.4 volts. We'll just call it 2.5. All right, so we're still going positive 2.5 and minus 2.5, even though we have a completely 100% DC input there that's just going in a triangle wave. So why is it that we still get that negative reference? Well, we got to think about what is actually going on in the circuit now. And so as the voltage source is charging, what are we doing? We're charging the caps, we're going down and fueling R2 and R3, so current's flowing in this direction. Just charging the caps up, going through the resistors, and when we're doing that, we can see that Vout is going to rise, right? It's going to get higher. But when the input voltage starts to drop, what happens is the input voltage actually becomes lower voltage than the output voltage of the standing voltage of the caps. And so when the capacitor voltage is greater than the input voltage, then what happens is the current begins to flow in the opposite direction. And then so we get current flowing backwards than what we would expect. We would expect current to always flowing out of the DC power supply, but when the voltage is lower than the capacitors, actually current is going to flow back into the DC voltage supply. And because it's flowing like this, and we got current going backward through R3, now we got to consider what's going on with the current flow and with these voltage sources. Remember, if I just hit a single voltage, if I just tap that once, it's giving me the voltage reference from Vout to this 0 reference, right? But my current is flowing in this direction, right? It is flowing from the 0 reference to Vout and through the capacitor, right? So our current is going in that direction. Well, because it's going in that direction, the only way current can flow is from high potential to low potential. And so if we're going to get current flowing from the 0 reference of the simulator to Vout, then that means that Vout has to be of a lower potential lower voltage potential than the zero ground reference. And so that is why we end up getting the negative voltage on V out. Well, that's all I have this time. Thanks for watching, and I hope you enjoyed the video. And thanks to all who have subscribed and shared. I'll see you next time. Have a good night.